Good evening, class. Today we're going to look at graphing polynomials and finding zeros. Our learning target for today's video is that you're going to sketch a graph of a polynomial and factor using the greatest common factor. Okay, the things we need to know to graph polynomials are we need to know the end behavior of a graph. We need to know the y-intercept of a graph, and we need to know the zeros, and we need to know the multiplicity of the graph. Okay, and multiplicity is something that determines what the function does at the x-axis, and we're going to talk about that more later. So I just want y'all to write that down and keep that in mind. Okay, the next thing we're going to talk about here is end behavior characteristics. And we talked about this last week, but you all really need to memorize this. So if you have an even function with a positive lead coefficient, you need to know that the end behavior is going to be up and up. Now if you have an even degree with a negative lead coefficient, it's going to be down and down. And then with an odd degree, excuse me, and a positive lead coefficient, it's going to be down and up. And then an odd degree with a negative lead coefficient is going to be up and down. And when we talk about this, we talk about on the left and the right. So we always do left, right. So then this would be on the left, on the right. Alright, so earlier I'd said that multiplicity is something that determines what the function does at the x-axis. Well, actually what multiplicity is, it tells me the number of times a factor appears. And we have different multiplicities. So if I have a multiplicity of 1 in my factor, and that would be example would be like, say I just had x or x plus 7. Okay, this is just a linear factor here. Then my graph behavior at the x-axis is that the graph will pass through the x-axis. Graph passes through the x-axis. Okay, now if I have a multiplicity of 2, which would be like x squared or x plus 7 squared, my graph bounces on the x-axis. And we saw that a lot in the quadratics because it bounces at the x-axis. Sorry. Okay, and then if we have a multiplicity of 3, which would be like x cubed or x plus 7 cubed, your graph is going to be an inflection point. Is an inflection point. It kind of flattens out, or it can flatten and bounce, and it just depends on your graph. And we'll look at each different examples. Okay, so now we're looking at finding some zeros of our polynomial functions. And either when you're given a polynomial, you might see it in factored form, where it's already written out in the binomial, linear binomial factors in factored form. And if you get it in factored form, then you're just going to set the factors equal to 0 and then solve for the x-intercepts, which are our zeros, okay, which are the zeros, and we should remember that from the quadratic unit. And then if you don't get it in the factored form, you're going to want to try to factor out the GCF first, and then you might have to factor a quadratic. And we did that in the unit with the quadratics, okay? So let's look at this first example here, example 1, and it is in factored form. So if I look at this, I can see if I were to multiply this out, I have 1x here, 1x here, and 1x here. So I would wind up with a degree of 3, which we remember from the fundamental theorem of algebra that I need 3 solutions. And if I look here, I'm going to get 3 solutions. Okay, and I look at these, and I'm going to have 3 distinct zeros because there's no repeats here. So I'm going to set x equal to 0, and then x plus 2 equal to 0, and then x minus 2 equal to 0. Okay, so then I'm going to have that x is equal to 0, negative 2, and positive 2. Those are my zeros, my x-intercepts. And then we're going to want to graph those and then sketch the graph of the polynomial function. Alright, so the first thing I'm going to do is sketch my x-intercepts. I know I have one at negative 2, one at 0, and one at positive 2. Okay, and then I'm going to go back and think about my end behaviors. Okay, so I know I have a degree of 3. My positive coefficient my lead coefficient is positive, so it tells me I'm going to be going down on this end and up on this end. Okay, so I know that I have some behaviors going on in between here. So if I wanted to sketch the graph of this, I could say, okay, what is going on at x equals negative 1? Well, I could put that in there. At f of negative 1, we could go ahead and put that into the function. I get negative 1 times negative 1 plus 2 times negative 1 minus 2. Okay, so if I solve this, I found out that f at negative 1 is positive 3. So, okay, at negative 1, I know my graph is up here at 3. I know at f at 0, that's my y-intercept, always when f is 0. So if I put f of 0, I put 0 in for x, 0 plus 2, 0 minus 2, so I'm going to get 0, so I know I'm going to come through here. And then let's look at f at positive 1. So I have positive 1 times 1 plus 2 times 1 minus 2. So this would be 1 times 3 times negative 1, so I get negative 3. So then I know here at negative 1, I'm down here at negative 3. So I know that my graph is going to go up, come down through 0, negative 1, and like that. So now I kind of sketched my first polynomial, my cubic polynomial there. Alright, so let's look at our second example here, and it's written in standard form. Okay, look here, my degree is 3, so that means I need 3 solutions because of the fundamental theorem of algebra. I'm not in factored form here, so I'm going to need to factor this out. So if I look here, what is my greatest common factor? Well, I can see that 3, 6, and 3, they're all factors of 3, and they all have an x in common. So I'm going to divide each one of these by 3x. I'm going to put the 3x on the outside of the parentheses. 3x cubed divided by 3x gives me x squared. 6x squared divided by 3x gives me 2x. And then 3x divided by 3x is 1. Okay, so now I'm left with a quadratic that I need to factor. So we just go back to our unit before here and we do our factoring. So my a is 1, so 1 times 1 is 1, and I need something that multiplies to give me 1 but adds to be negative 2. So my only factors of 1 are 1 and 1, and if I multiply this by negative and negative, I get a positive 1, add them together, I get negative 2. So this becomes 3x times x minus 1 times x minus 1. Okay, so I see that these are exactly the same. So this is going to be where I have only 2 distinct zeros. If I set these equal to 0, 3x equals 0, x minus 1 equals 0, and x minus 1 equals 0, I get x equals 0, x equals 1, and x equals 1. Okay, yes, I have 3 solutions, but I only have 2 distinct answers. I have 2 distinct solutions, and then I have x equals 0 and x equals 1, but this has a multiplicity of 2. Okay, spelled too well. Okay, so let me erase that and spell it multiplicity. Multiplicity of 2. Okay, so now we just want to graph those. Okay, so we graph our zeros, which is the same thing as our x-intercepts. If I put 0 here, my y-intercept. My y-intercept is going to be 0. And then I have another 0 at 1. Okay, so I know that I'm going to have a bounce here. I'm also odd and positive, so I'm going to be going down and then up. So up here, but I kind of like to know what's going on in between here. How high do I need to go up and come back down? So we could always look at the point in between here and get a value. So if I want to figure out what f at 0.5 is, that means I just plug that in. So if I put that into my original equation, I put 3.5 squared cubed, sorry, it's cubed, minus 6 times 0.5 squared plus 3 times 0.5, and I get f at 0.5 is equal to 0.375. So I know I'm just going to go up just a little bit. So my graph is going to look like this, where I go up, hit 0.375, hit 1, and bounce. So remember right here, this is a bounce, and where I have the multiplicity of 2. Multiplicity there. Alright, so our graph here, our next example is given to us x to the 4th minus 2x cubed minus 8x squared. I don't have, it's not in factored form, so we need to factor out a GCF. I see that I have a degree of 4, so I need 4 solutions. Okay, so let's factor this out. So my greatest common factor is going to be x squared. So if I divide everything out by x squared, we get, put that on the outside, I want it with x squared minus 2x minus 8. Okay, so I'm left with a quadratic on the inside that we need to factor. So I need factors of negative 8 that add to give me negative 2. So that's going to be negative 4 and positive 2. So this factors out to x squared times x minus 4 times x plus 2. Okay, we said our factors equal to 0. I have x squared equals 0, x minus 4 equals 0, and x plus 2 equals 0. Alright, so here I know the x is going to equal to 0, but I have a squared, so this is going to be a multiplicity of 2 here. Right here. I'm going to get a bounce at x equals 0. And then I have x equals 4, and then x equals negative 2. Okay, if I plug in 0 up here to get my y-intercept, you always need to know that. My y-intercept is x equals 0, so here will be 0, so I have that. It's also one of my zeros. I know I'm going to be bouncing at 0, so, but I know I'm crossed here at x equals 4 and negative 2. Alright, so if you want to figure out, I have a degree of 4, so that means I'm going to be up on the ends. My 2 degrees will be up and up. We know that. I'll be up on the right, up on the left. So, what is going on at negative 2? So, I know I'm going to be coming down. So, what happens at negative 1? Alright, so if I want to see f at negative 1, I plug that in. Negative 1 to the 4th minus 2 times negative 1 cubed minus 8 times negative 1 squared. Okay, if we did this, we get that it's equal to negative 5. So, at negative 1, I'm at negative 5. And and then, okay, so I have those two. I have 2 and 0, so, and I know I'm going to come down here and hit and come up and bounce, and I went ahead and looked at f at negative 3 is negative 45, so that'll be like way down off the chart. I'm going to come up and hit this 4. So my graph is going to look like that. Okay, so in review, we need to know in order to graph a polynomial function, you need to know the end behavior, the x and y intercepts, and the multiplicity. Make sure you write down any questions you have. Make sure you take notes, complete the form, and I'll see you tomorrow. Thanks. Good night.